Okay, I'll slowly actually start with the introduction part while people are still joining. We had more than 50 participants accepted on a meetup, so let's see how many of them will join. So welcome again to the meetup, to July meetup of Stuttgart user group. Again, recording is in progress, so if you missed something being disconnected or you want to watch it later, you can find it on Power Platform User Groups Germany, and also join us on Meetup. Again, like pretty much this all the time, myself and Christian here doing the hard work introducing somebody. And so few upcoming events. So today we'll have one, then the next Thursday, the last one before well-deserved summer break. So next Thursday, James Dales with also like today, pretty much premiere presentation for the public is pushing the boundaries of mapping in Power BI. And then after summer break, we'll have in September Matthew Roche with pretty much the hot topic today, building a data culture with Power BI. So that one is waiting for you after summer. And while I was thinking how to announce today's session, this picture actually, first one came to my mind, is trying to squeeze as much things as possible in a small space, which is usually our Power BI desktop and our memory we have available. So Nikola, welcome again. To the Stuttgart Power BI user group, and I think this session was this blog post was getting a quite attraction on LinkedIn with lots of comments and everything. So then we figured out it would be interesting for a bigger audience that you presented on your own.
Yeah, awesome. Thanks, Agustin. That was great. Yeah, the picture was awesome, really. And yeah, thanks again for inviting me and giving me a chance to present. As you said, it was a blog post, and a lot of people interacted on LinkedIn and Twitter. So I didn't have a session prepared for this, but when we talked after this post. Yeah, as per your suggestion, I think indeed that was a great suggestion to create a session to maybe explain in more details how all of these things work in the background. Yeah, so I think it will be useful for the attendees. Yeah.
Yeah, I hope so. Let's show is yours, so you can share the screen.
Okay, great. Thanks. So I'll start sharing. Okay, fine. So let's just move this here. Perfect. So good afternoon, everyone. I think I can safely say good afternoon. I think most of the people are in Europe. In any case, good afternoon or good evening. And first of all, I would like to thank Augustin and Christian for giving me a chance to present again at Stuttgart Power BI user group meeting. And I'm really happy to be with you here, especially because this is, as Augustin said, the premiere. I'm presenting this session for the first time. Today we will talk about some data modeling, and it's not just a basic data modeling, things like star schema, which is, by the way, extremely important topic itself. Today I want to show you how to build efficient data model in Power BI over a 200 million rows table, and how to fit this table in approximately 30 megabytes without sacrificing the report performance. I know you think I'm nuts, and I can hear you talking, maybe, Nikola, are you crazy? 200 million rows can't be accommodated in 30 megabytes. There is no way. Well, technically you are right, but practically I'll show you how you can make enormous memory savings while at the same time preserving performance with some neat data modeling techniques. Before we start, just a brief introduction. My name is Nikola Ilic. I'm originally from Belgrade, but for the last 5 years I live in Salzburg, in city of Salzburg in Austria, where I work as a business intelligence developer at company ITSP Services. I choose my nickname Data Mozart because I live in Salzburg. I guess you all know that Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart. That's the reasoning behind this nickname. And that's why my motto is make music from your data. You can find me on web. I'm regularly blogging at data-mozart.com. I'm also pretty active on Twitter and LinkedIn, so feel free to connect if you like. Other than that, I'm Microsoft certified trainer and data platform MVP, privately father of 2 kids, and through football and Barca fan, as you can conclude looking at the photo on your screens. So when we are dealing with technologies, sometimes we need to accept the fact that there are certain limits, certain boundaries, especially when it comes to resources available. And sometimes, maybe more often than not, or maybe more than we would like to, business requests are such that it's hard or almost impossible to implement them within the current setup. So a few months ago, I faced a quite challenging task to migrate SQL Server analysis multi-dimensional solution, all good old cube, to Power BI. The only issue, let's call it issue, was that the client has pro license, which means 1 GB model size limit. And there were approximately 200 million rows in the fact table, and this table was constantly growing, so on a daily basis. And I knew at first sight that there is no way to accommodate 200 million rows in under 1 GB, no matter how narrow and optimized your table is. So despite applying all these best practices for data model size optimization, such as removing unnecessary columns or trying to reduce the cardinality of the columns, here it simply wouldn't help and it wouldn't work. And in the end, it looked like it's impossible to do something like this. So when I was start thinking about the possible solutions, the first and most obvious idea was to use Power BI simply as a visualization tool and just do a live connection to a SQL Server Analysis Services cube. However, this solution comes with some serious limitations, and the most remarkable one is that you can't enrich your semantic model by writing report level measures. So all measures, all calculations need to be done on the SQL Server Analysis Services side. And that was one of the key clients' requests, to enrich report with new measures. Therefore, live connection was immediately discarded. The second obvious solution was to use direct query mode for getting data into Power BI. So instead of SQL Server Analysis Cube, Power BI will directly target fact and dimension tables from the data warehouse. And despite all its limitations, direct query looked, like a completely legitimate and the only possible solution. And this was the best I can thought of. Until I found Phil Seamark's blog post about filter aggregations that opened a whole new perspective. For those of you who don't know, Phil Seamark is a program manager in Microsoft's Power BI customer advisory team. He has a really great blog at dex.tips. And this whole series on creative aggregation is well worth reading, believe me. And this part for filter aggregations, so this concept was like an enlightenment for me and for my case. So let me try to briefly explain the idea of filtered aggregations, or let's call it filter aggregations in a nutshell. Of course, I will try not to go into details about the concept, as Phil explained that much better than I ever would. Essentially, here is the idea is to separate hot and cold data and then leverage the composite model feature in Power BI. That way that you will import the hot data in Power BI, while cold data will stay in the data warehouse and be targeted through direct query. On top of that, applying aggregations within the Power BI data model will bring even more benefit, as you will see later. Now, I hope you're familiar with the terms hot and cold data. For those of you who are not, hot data is the most recent one, where word recent has typical it depends meaning. It can be data from last 3 minutes, 3 hours, 3 days, 3 months, 3 years, so on, depending on your specific use case. In my case, after talking with future report consumers, we've concluded that the most of the analysis focus on the data from the previous 3 months. Therefore, the idea is to extract hot data dynamically as the data from 3 months prior to today's date and store that data in the Power BI tabular model, so in memory. Report consumers will benefit from fast queries as data would be optimally compressed and kept in memory. On the other hand, when older data is needed for analysis, so cold data, Power BI will go directly to a data source and pull the data from there at the query time. Finding that tipping point, I call this tipping point. So this is the point in time to separate hot and cold data is of key importance here. If you decide to use a shorter period for hot data, you will benefit from having a smaller data model size as fewer data will be imported into Power BI. But then you will have to live with more frequent direct query queries, which means performance decrease. So it's a kind of trade-off. Basically, you are choosing between reducing the data model size and query reduction to improve the report performance. But enough theory. Let's jump to Power BI desktop and I will show you all the steps to fit your 200 million rows fact table in less than 1 gigabyte. Okay, so this is the starting point and I want to show you that I have fact table with 200 million rows in it. So I imported only fact table, nothing else, no dimensions. We will work with dimensions in another file. This is 200 million rows imported in Power BI. And if I open DAX Studio to check the size of this data model, let's wait for a few seconds. Just be ready to wait. At few points, you will need to wait for some time for demo to execute because it's a lot of data and I'm on my personal PC, not so strong machine, but yeah, hopefully everything will work fine. So if I go to DAX Studio and click on Advanced and View Metrics, you can see that my table has cardinality of 200 million. And if I click on Summary tab, let me zoom it a little bit. So total size of my data model is 2.36 gigabytes. So let's round this to 2.4 gigabytes. That's our starting point, 2.4 gigabytes. So there is no way for this to be accommodated in Pro license. I will close this one because we don't need it anymore. And let's switch to another PBIX file. I will explain what I did here. So here I splitted this one giant fact table of 200 million rows in 2 separate tables. And I called those tables fact 200 million cold and fact 200 million hot. Hot table has around 7 million records and remaining 193 million are in the cold table. In total, that's 200 million. And I want to show you the logic behind the data for both of those tables. So let me just open, because SQL query populates data here in both of those tables based on this tipping point, which I explained previously. So here is the source query, or let me show you in SQL Server Management Studio, it's more readable here. So basically, what's the idea here? This is the hot part. And by using this end of month and get date T-SQL functions, basically I'm retrieving data from last 3 months. So this is dynamically calculated because get date will, in the moment of execution, it will return current timestamp. So every time I go and refresh my data set, this will give me data from previous 3 months. Down below is cold part. So basically everything is the same. This is the only difference. Here is greater than, so after in last 3 months. This is prior to this tipping point, so data older than 3 months. That's the whole logic here in our tables. And this is just a sum of those two. So as you see, yeah, nothing special. And one important thing to keep in mind here is you need to ensure when you are separating data to hot and cold tables, you need to ensure that there is no overlapping between these two, but also no gaps in between. So you get a correct result in the end, because when you are displaying results totals, you need to include both cold and hot data. So as I said, I've created those two tables, and both tables are in direct query storage mode. You can recognize this based on this blue line on the top here. That means that table is in direct query storage mode. So the idea is to build aggregated table over hot data here, and this table will use import mode. On the other hand, cold table, which contains remaining 193 million rows, it will use direct query mode. On top of it, I will build few aggregated tables to cover different dimension attributes, such as the date in my example. So I don't have any other dimension tables here. I will cover only the date dimension, and also use import mode for this aggregated table. So Power BI will need to switch to direct query and target original data source only for those queries that are not served with import mode tables. Okay, that's it. So let's start now implementing our filtered aggregation solution. And I will go to transform data. And I will, the fastest way to do this is to duplicate my hot table. And I will call this fact 200 million hot aggregated. Hit close and apply. And let's wait for Power BI to put here. That was fast, fine. Now I will create a relationship between my date dimension and this newly created aggregated table. So date to date UTC. Okay, that's fine. Now, yeah, the performance of this report would depend on many things. If the user tries to interact with the report and wants data older than 3 months, Power BI will go and search for that data through the 119 something million rows stored in the SQL Server database, having to cope with network latency, concurrent requests, and so on. Few more things before we proceed further. First thing, I will right click on this table and click Manage Aggregations. So I want to create aggregations within Power BI, and I will do a sum of my amount column from the hot table, and I want to group by date UTC from hot table and date UTC. By default, when you create aggregations in Power BI, this table will be hidden, so it will not be visible to end users. Next thing, this is the key step. Again, if I click on this table under Advanced, here in Properties under Advanced, I can choose storage mode for my table. At this moment, this table is in direct query storage mode, and I will switch this to import. So I want to import data in Power BI. And let me just stop here for a second. So I'm being warned that if I change from direct query to import mode, this is irreversible operation. So I will not be able to revert it back to direct query. Keep in mind that you can switch storage mode from direct query to import, but vice versa is not allowed. Anyway, I'm sure that I want to do this, so I will confirm, and let's wait for a few seconds, because now Power BI imports data in tabular model from our SQL Server database. So it has around 6 point something million rows. That goes fast, I think 15-20 seconds. And we are good to go. Okay. Just a few more seconds. That's it. Okay, I will duplicate this page. And let me just get rid of those Okay, I will remove those visuals. We don't need them for this part of the demo. And let's say that I want to analyze total amount, which is the simple sum over amount column. So in order to retrieve the correct figure, totals, I need to sum values from both hot and cold tables. Let's put some simple visual here, column chart, and let's create a new measure, which I will call total amount hot and cold, and it equals, so we will use, I'll use variables, it's easier to read. So amount hot equals sum of amount from our hot table, and the other one, amount cold, equals sum over amount from our cold table. And finally, I want to return just a simple addition of those two, so amount hot plus amount cold, and that's it. Let's drag this measure here, and let's, for example, use year on our axis. And now we will need to wait for Power BI to render the data for this visual. It can take maybe even 30 seconds because don't forget that we have 200 million rows in the background, and we are using direct query mode. And we are retrieving data for the whole data set. So from 1st of January 2017 until the, okay, this is the end of this year, but we have data until July 2021. So Power BI will definitely need some time to render this data. And thanks for your patience. If there are any quick questions at the moment, I will try to answer them until this is done, so we don't waste any time. Okay, as far as I see, no questions so far, which is good. So either everything is clear or everyone is still confused, but no worries. So we are still waiting.
Just a question from my side.
Did
you try to trace the query which is going for this visual? How it is that it's taking so much time?
Yeah, because it executes as a direct query.
Okay.
So completely retrieve 200 million rows from SQL Server. Yeah. Nothing is in Power BI. And that's the interesting part, because okay, now we retrieve the whole data, but at least I would assume that if I want to see only data from the last 3 months, Power BI will not need so much time, and will go only and to this aggregated table that we created, and quickly pull the data and render the visual for us.
Okay.
But that's wrong. So let me show you. I will turn on Performance Analyzer and start recording. And for example, let's say that I will take data from the last 3 months, or let's say from 1st of June 2021. And now you will expect that this is served from our aggregated table. And it took 1.35 seconds, which is not so bad here. But if I expand this, you can see that we have direct query here. And direct query took almost 100% of the time needed for execution. Because if you deduct this time from DAX query took 26 milliseconds, which is, yeah, irrelevant. So why do we have direct query when we have our table in import mode? So Power BI is smart. In fact, it is very smart, and it was smart enough to internally translate our sum over amount column and hit this aggregation table instead of visiting its direct query twin. However, there are certain situations when Power BI can't resolve everything on its own. And in this scenario, Power BI went down and pulled all the data, even from the cold table, from the cold direct query table, and then applied date filters on the whole data set. And that means we need to instruct Power BI to evaluate our date filters before the data retrieval. So it first needs to evaluate date filters, and then based on this evaluation, decide if it needs to retrieve data from direct query or if it can be served from import mode. And again, thanks to Phil Simark for the improved version of the measure that I will show you in a few minutes. First thing here is to set our tipping point. You remember this 3 months tipping point in time index. So we will use exactly the same logic as in SQL when we were splitting our giant fact table into hot and cold part. So I will just stop this for a moment and let's go and create a new measure. So we are now defining our tipping point, and I call this measure timeline. It equals, again, I will use variable and let's call it max date. And it equals, so we will use calculate here to change the filter context. And I want to retrieve maximum value from my date UTC from aggregated table, because that's the table I will use. And I want to remove all the filters from this table. And finally, I want to return end of month. So basically the function is the same as in SQL. And as a start date, I will define my date from the variable. So I want to pull year from my variable. And I want to pull defining months is the key thing here in this measure. So month from my variable -3, because I want to go 3 months in the past. In case that you want to define your tipping point 6 months in the past, you will put here -6. So it's just how long do you want to go in the past. And finally, I want to retrieve from the first day of this period. And that's it, basically. And now we are able to set the cutoff date between the hot and cold data index. And then we will use result of this measure in improved version of our total amount hot and cold measure. So here, this first part for the hot amount stays the same, but for the cold, because it will be, we want it to be served normally from aggregated table. But for the cold amount, we need to apply some additional logic. So I will use if logic, and I want to do evaluation within the if function, and I want to say if the minimum value from my, what's the name of the date. So if the minimum value from my slicer, from my date dimension, is lower than value of my tipping point, so the measure that we just defined, okay, in that case, return me sum over cold amount. Okay, everything else remains the same. So here, just let me once more reiterate through this measure, because this is important. So in every scenario, we are returning sum over profit column, over amount column from the hot table, as it will always hit the aggregated table in import mode. That's what we want to do. Then we are adding some logic to cold data, checking whether the starting date in the date slicer is before our tipping point. If yes, then we will need to wait for direct query. No help for this. But if not, so let me show you again. Okay, and I will start recording again in Performance Analyzer. And let's say that I want to use, check now data from 1st of May. So we are still in our 3 months hot period. So if I click on 1st of May, bam, that was like half of a second. No direct query this time. So you see that this time Power BI evaluated our date slicers and saw that it's in last 3 months. Okay, I will go just in aggregated table, hot data, pull that from there. I don't want to use direct query. Or, again, if I go, I don't know, for example, 15th of June, you see that it works fine. No direct query here. So let me show you how this translates in the background. I will copy my DAX query here, and again, I will open DAX Studio. So now, as Augustin said, we will trace the query and what's happening under the hood. I will turn on server timings and let's paste our DAX query here and run it within DAX Studio. And in server timings, let me show you this row, rewrite A, so match found. If I click on this, that means that Power BI hit our aggregated table. And you can see match result, match found. Our original table is 200 million hot, but it was internally mapped within Power BI. It was internally mapped to our aggregated table. And that works really fast. Okay, I will close this. Now that's fine, as it means that most frequently running queries which targets data from the previous 3 months will be satisfied using the import mode aggregated table. And we could stop this. We did our job. We accommodate 200 million rows. Everything is fine. But the next step in optimization is to somehow improve the performance of the cold data. So if someone wants to see a record from 4 months ago, it will go, direct query will be executed on the SQL Server database, and it will need to go through 119 million rows to find data, which is still not so old. So as the next optimization step, I want to build an aggregated tables over cold data that could potentially satisfy the most frequently ran users queries. And these queries which need to pull the data before the tipping point, older than 3 months. And that will slightly increase the data model size, but it will significantly increase the report performance. So let me show you just for a second the size of this current data model in Power BI. So we will go to Advanced tab, View Metrics. Let me just, or maybe I need to stop Performance Analyzer first. I want to show you, okay, let's try again. So DAX Studio, and just to see the difference when we use some additional aggregated tables. Okay, we can start building this until this is executed in DAX Studio. We can start building the next step, the next optimization step in our solution. So I will go back to Power BI and open Power Query Editor as I need to build a new aggregated table. So the idea is only in some specific, really specific use cases when user needs to see some low level of grain within the cold data, Power BI will need to use direct query on the underlying database. So let me go here and create a new query, SQL Server. Let me just provide a location and 12. And instead of direct query, I want to use import mode. And I want to write my SQL query to retrieve the data. So basically, I want to do aggregation on my date UTC column, and I want to sum amount value as amount from fact 200 million, where end of month, where date UTC is lower. So we just want cold data. We don't want to touch hot part here. So we just want to retrieve from this part which is older than 3 months. And here is end of lower or equals to end of month And I need to provide some arguments. Date add, it's month -3 and get date. So we get current timestamp here. I think syntax is fine. Let's click OK. And yeah, so let me show you here the summary. We have 31.29 megabytes. So this is the size of our data model. Now, when we did direct query over cold data and import mode for hot data. Okay, edit. So I didn't do everything. Yeah, I forgot group by. So I need to group by date UTC. That should be fine now. We'll quickly see. So if there are any questions, every time we wait, so yeah, we can. I can try to answer. Okay, this is done, and let's call this one date UTC aggregation. Okay, I will hit close and apply, and Power BI will now import this data into memory, so in tabular model. Everything else remained the same. Let me quickly look at the chat window if there are questions. Nothing at the moment. Okay. Sorry that you need to wait for almost every step, but yeah, that's when you're doing live demo, that's the trade-off. That shouldn't take long because we don't have too many rows. That's fine. And I will now go to model view in Power BI desktop because we need to define some additional stuff before our solution can work. So first, I will build a relationship between my new aggregated table and my date dimension. I need to set, we don't want one-to-one and we don't want bidirectional filtering. Okay, that's fine. And now I will set aggregations for my newly created table. So I will right click on it and manage aggregations. And here I will set precedence value of 10. By setting the precedence property, you can instruct Power BI which aggregated table to use first. The higher the precedence value, the higher priority gets respective table. So you can combine multiple level of aggregation precedence when you're working with aggregations in Power BI. And I want to do sum of my amount column from the cold table. And I want to group by date UTC value from my cold table. Fine, I will apply this and let's go back to our report. So now we will check the performance of our measure once we include the data from before the tipping point. So data older than 3 months. Let me start recording and let's see what happens if I choose here, for example, 2020, January 1st, 2020. Oh, slightly more than half of a second. No direct query. DAX query took only 66 seconds. If I change this, for example, to, I don't know, 2018, so 1st of January 2018, again, it's less than half of a second. No direct query. Again, DAX query took 52 milliseconds. That's awesome. So I've expanded date range to the previous, I don't know, 2.5 years, so 30 months, and we got our results back in half of a second, while DAX query took only 52 milliseconds. So I will again copy this query and go to DAX Studio as I want to check again the trace of this query and what happened under the hood. So in the background, what happened and how Power BI retrieved data so fast. So I will turn on server timings and I will paste my DAX query here and run this query. Okay, so now we have 2 times this match found shown in our query. Let's go and check first this one, and you can see that our cold table, so when we needed to pull the data from our cold table older than three months, it was nicely mapped to our newly created aggregated table, and data was served from this aggregated table. Also here for the hot data, again, it was mapped to our aggregated table over hot data. So basically both parts, we can confirm that both parts of our request for both cold and hot data were served from import mode aggregated tables. Before we draw a conclusion, let's take one more look to our data model size. Let me close this one. Sometimes it slows down DAX Studio metrics, so it will take some time. But last time I think we had like 31 megabytes before we added this aggregated table. Of course, in my demo example, I had only one dimension table and I built only one aggregated table. In real life, if you have multiple dimensions, you can build multiple aggregated tables. They will still not occupy so much space. It will not take too much of your memory, but they will significantly improve your the performance of your report. So if I now go to summary, it's less than 1 megabyte, because this is a small table. Data table maybe has 2,000 rows. Anyway, if you are creating aggregated tables to improve the performance of the queries for cold data, keep in mind that they will take some memory footprint, but not so significant. So basically, in the end, we finished with 31.3 megabytes. Just recall where we started. We started with 2.4 gigabytes, and now we are at 31 megabytes. So before we draw a conclusion, the original request was to move a data model from SQL Server Analysis Services Cube to Power BI Workspace, Pro Workspace, without losing any of 200 million rows from the fact table. And as I said, we started at almost 2.4 gigabytes and finished at 31 megabytes, while preserving original data granularity and without impacting the report performance for 99% of use cases. So only in some extraordinary cases, when user needs to see some really low level of granularity within the old data, Power BI will fire direct query to a SQL Server database. As I said, extraordinary tasks require extraordinary solutions. And if you ask me, thanks to Phil Simark's awesome idea, we have a solution to accommodate extremely large data even into pro limits. Essentially, what we've just done is that we've managed to fit 200 million rows in 31 megabytes. I will close this. That's it from me. Well, looking forward to hearing your questions, impressions, whatever. Yeah, feel free to drop into chat, or Augustine, if there are any questions, just let me know. I will also open the chat myself. Yeah, as far as I know, recording will be available. That's the question.
Yeah, recording will be available as always, I don't know, a day or two after. So whenever I found some time to publish it on YouTube.
Yeah, check other presentations, yeah, because there are a lot of really great sessions in the past. Thank you, Ludmila and Andrea. You're welcome, Stefan. It was shorter than 60 minutes, but yeah, I wanted to keep, everything.
Just one question from my side, Nikola. Mm-hmm. So, did you think of anything which can be similar to this if source is not on a SQL database? If source is, I don't know, flat files or something?
Well, that would be much harder because I'm not sure how would you split dynamically data if it's in flat file.
Yeah, just thinking loudly, actually.
Yeah, sure. It's interesting, great question. Maybe you can do something if you, for example, use Synapse and then partition your files. So you build basically, you partition your files using this file path function, and you have files for each day, and then you can write SQL query to get data from those files and pull data from from those last part of the files. So from the most recent one into hot table, and yeah, that's interesting. Maybe good topic for a blog. Yeah. I'm not sure. I'm not 100% sure, but that it's doable and what will happen in the background, but can be done, I think so, because you can partition data in Synapse if you are targeting, for example, CSV or Parquet files.
Yeah, sounds interesting approach. I'll take a look and try it.
Yeah, great. Let me know about the findings. I would be interested to hear.
Sure.
So also from my side, thanks a lot, Nikola. Great presentation, and it really interesting.
So you are muted, Christian. I just heard the first part of the sentence.
Myself.
Yeah, it's okay now.
Okay. It's a delay on my side. I think there's a delay on my side for the mute button and unmute button, so I accidentally muted myself. But thanks also from my side. Great and interesting topic, and really nice presentation.
Thank you.
Don't think there are any other questions. Let me check the chat again. But I don't see anything. So, yep, there's nothing in the chat on my side.
Thanks, Taras. Thank you. Glad that you liked it.
Of course, it's okay if anybody wants to stay. But I guess we can officially then close the session for today. And thanks again for everybody for attending. As Augustine said, the meeting recording will be available shortly on the channels that they used to. So will be shared in the YouTube channel, and in the meetup, the link will be posted. And stay tuned, as always, for the upcoming events. Thanks, everybody, and have a great evening.
Thanks from my side to all who attended. And thanks for having me, Agustin and Christian.
Much appreciated.
Thanks, Nikola, for joining, and you are always welcome here. So don't worry. And I think with this session, you actually managed to explain all the confusions that were on the blog. So
hopefully, hopefully, yeah. A lot of people ask for videos, so yeah, I think it's easier when you can, some things you can't explain with images and just plain text. It's easier to follow step by step everything.